Hello. Welcome to devOSH Live. We'll be starting momentarily. Sit back, relax, enjoy your flight. Fixer, are you coming on to this stage with me or what? See, no. All right. So welcome everybody to the latest edition of devOSH Live. Today we're going to go over what's happened since the last show. There was this little thing called open source that I got to attend, which was fun. And I'm hoping Fixer jumps on to talk about it as well, because he got the premier experience. I only paid for like the plebe experience. But I got some extra perks from knowing people, like seeing the robotic fight, which was fun. All right, so let's see. Let's see if you can join the stage. Fixer, can you hear me? Guess he doesn't want to speak live, or he's not prepared yet. So we're supposed to have Kevin and Mark from Delta joining. They were also at Open Source, and they actually had a booth, and I'd like for them to share their experience as well. So if you don't know what Open Source is, it's a kind of a content creator / maker extravaganza that happens once a year. It's getting progressively larger. At least that's what I've seen so far. It's a lot going on, and it's kind of overwhelming. But it's probably as big as a maker fair, but also has presentations, stages that actually have content creators out there doing their thing, making chat with other creators. I sat down for a few of these. I think the one I saw was with Sean Hodgins. He did a presentation or a chat fireside with his fellow techie nerds. I think he led the conversation, actually. Let's see what that was. I think it was on Saturday. Let's see. Maybe it was on Friday. There it is. So yeah, this one's kind of irrelevant to our group. And it's a panel about the art of electronics. It was quite fun. So we got some cool pictures that Fixer will be sharing out on social media. Looks like Kevin joined. Let me go ahead and pop him onto the stage. How you doing, Kevin?
I'm doing great. Can you guys hear me?
Yep, loud and clear.
All right.
So yeah, I was just talking about open source, and I figure you want to probably share your experience as kind of a booth runner.
Yeah, as a sponsor. So they've got sponsors, exhibitors, and attendees and then YouTubers. They've got a bunch of different categories. Me and Mark like to think that we don't know this officially because we're not on the open source team, but they've got like priority levels where YouTubers are typically at the very top because that's what people come for. But
Yeah.
then right next to them, it's like the highest tier sponsor level. It's like Crunch Labs or Prusa, or in this case, GMC this year, where they pay the highest price tier that they have, and then they get special treatment and have their own special tools and booth and all this stuff. But right below that, you've got the other tiers of sponsors, which we were at the very lowest tier. But we still made it on the banner. Our logo was in there. So our experience was awesome. It's really interesting every single year. For the first 2 years that we went, it was kind of it was a hot mess. I'll say that. I'll say that it was absolutely amazing. It was absolutely fun, and would go even if it was still a hot mess.
Of course.
But I think everybody was still trying to figure out how to make all this stuff actually work and not lose a bunch of money doing it. For the first 3 years, I think. And then this time around, it really felt like, wasn't perfect, but it really felt a lot more polished, especially on the sponsor side of things. Like they took care of us. They had people, if we were missing something, I forgot to bring these 2 little bullet connectors for recharging my battery. I brought the charger, but not the adapter. And so they had staff running around designated zones, and they're asking like, hey, like, what do you guys need? Y'all missing anything? And we're like, we're missing a battery charger. You wouldn't happen to know anybody? And they're like, well, let's go find out. So about an hour later, they find somebody, and we managed to get a battery charger.
Nice.
So the experience as a sponsor was really, really awesome.
Good. Yeah, it seemed like you guys had a great time, but maybe we're a little tired towards the end. It's a lot of doing.
My feet still hurt. My biggest recommendation for anybody that's interested in running a booth, especially as a sponsor, it's all about, what is the output? What is the outcome that you're trying to get out of having a booth at OpenSauce? Is it to get connections? Is it to build a network? Is it to tell people about your product? Like, what is the entire goal? For us, we were showing everybody Protoboard. We just launched a bunch of updates, and we actually showed off Protoboard for the first time last OpenSauce, and this time around, fully functional. And so we wanted people to take a look at it, give it a try, and we were showing off some cool artificial muscles we built using Protoboard. And with 2 people only, that was incredibly difficult because I think last year we had a little ticker, and we got maybe 600-700 people at our booth, like actually talking to us and through the booth. And if you don't have more than 2 people, you're constantly up and talking to people because the rotation flow, it's like you show people something awesome and they sign up or don't, and they move on, and then the next person floods in. That is constant. So for anybody that's looking to have a booth at OpenSauce that wants to have some sort of flow like that, definitely recommending bringing more people to rotate with, because we were so busy that we didn't really get a chance to go and talk to a bunch of the other booths. Like we had
that would be frustrating.
Which is fine. We definitely got what we came for, but there were so many cool people there that didn't get a chance to leave their booth either. And so we missed an opportunity to talk with them. And we had to physically leave our booth. So if we could have missed 100 people coming to our booth and talking to them, because we decided that we're going to take 30 minutes and we're going to run around real quick and find some a select few to talk to, and then rush back. Or we trade off. It's like, hey, dude, like I really need to go to the bathroom. It's like I need you to man the booth for a little bit. And it's like, all right. And then it floods in, and I don't know. This is all kind of like overwhelming, but honestly, I would do it again in a heartbeat. I'd bring some insoles next time. That would be my biggest thing.
Definitely. And I think like as your kind of company grows, you can bring more people to staff the booth, find
Mhm.
some interns to do it for you, some enthusiastic and well-informed interns, because you can't you can't just put anybody there and they won't just, I mean,
Mm-mm.
they'll just stand
Yeah,
there and it won't work.
if it's just a booth showing off something cool, I think that's
Yeah.
fine. There's
There's
no like,
plenty of that. There's so much of that.
yeah, that's fine. Like you could have anybody staff it and just be like, yeah, yeah, here's a link, you can learn more about it, and they'd be like, oh, cool, yeah, they capture it. But for us, we wanted to capture leads. We wanted to capture people that would be interested in giving Protoboard a try and have a conversation after open source. So
Yeah.
we were trained. We knew what it was. We knew how to sell it. We knew all this stuff. But if we were to bring somebody in, they would have to know a lot about that system as well. I'll give you a great example. One of the conversations I had, which was absolutely phenomenal, there was a startup. There was an employee from a startup that was building a VR headset.
Okay.
I won't mention their name on live stream here, but or the startup they were working for, but I didn't know any of this. So I'm talking to them. They're like super interested in what we're doing, the artificial muscles we brought, the proto board that we were showing off, and like just having a good conversation. And he's
Yeah.
like, "Oh yeah, that's pretty cool." And it wasn't until I asked him, "Hey, like, what do you do? Like, what is your job?" Where he then goes, like, "Yeah, I work for this so and so startup as a hardware engineer."
Oh, wow.
And it immediately clicked, and I said, "Holy cow, that's awesome! You guys have some of the best VR gear out there. What
Nice.
does your prototyping flow look like?" And he's like, "Oh yeah." And then all of a sudden, it shifts because what we found is people really love talking about themselves. If you can get to a position
Yeah.
where they just talk about themselves and the cool stuff that they're doing, they'll keep going. And that's exactly what we want. We want insight from that conversation. And so
Yeah.
he keeps talking. And he basically said, yeah, so the biggest bottleneck for us right now, like software with all the AI coding, I know people have their quorums about it, but software is really, really easy and really fast right now. And so the biggest bottleneck for us is building hardware, testing hardware, because we have to order, reorder, retest over and over and over again to complete that cycle so that they can bring it out into the final product. And that was the perfect segue to be like, holy cow, that's exactly why we built Protoboard, because it'll
Nice.
let you test all of your hardware virtually, prototype virtually before you order any parts. That way your build time, your prototyping time is dramatically reduced. Your cost dramatically reduced because you can now validate beforehand. And once I said that, once his world was framed into this nice little box, that's when it clicked, and he goes, "Holy cow, that sounds exactly like what we need. I'm gonna sign up right now." And boom.
Cool.
It was a long conversation, but we wouldn't have had that insight if there wasn't that opportunity to really talk to them. This is
Right. Well,
where
yeah. You want a
this is
long
where all the work
conversation
comes from.
sometimes.
Yeah,
Yeah.
yeah, for sure.
I mean, you showed value in, like, you made a conversion or whatever. You got one of them in the funnel, as Fixer likes to say. Now, just got to make sure that they feel like they're welcome, and of course they are. That I think it's tough, like, getting like direct feedback unless they join like your Discord.
Hmm.
Yeah, and
Yeah,
some people just don't do that. They just don't want to deal with it.
yeah.
And
What we learned, and it feels kind of weird. This is a open source hardware kind of conversation, but in which there is a tie-in. I'll loop all of this full circle. Don't you worry.
all the way back.
All the way back, and we learned the first two times we went to open source, we learned pretty fast that we can't take people's word for it. It's such a weird human behavior. It makes perfect sense because that's what we do too. But if you're like, oh yeah, here's my QR code, go check us out. Like, we're building something really cool, go check us out. They scan it, and we will never hear from them again.
That's
And
like
it's not. Go ahead. Yeah.
Sorry.
But it's like, I mean, we give people the opportunity. They're going to go at it on their own time, which is completely fine. But it's incredibly frustrating when you put so much effort and so much time into talking to them, having that conversation, all for it to just fall completely flat at the end of the conference. So this time around, we specifically built a sign up form. And it's a little bit of a social engineering, a little bit of human engineering here, because you're kind of forcing them into this funnel that's like, hey, sign up. We're not asking for personal information. It's literally just like, put your email here because we'd like to continue this conversation.
Yeah.
And at that point, if they still don't reply to any emails that we send out or communications, all right, we'll let them go. But after an event like that, it's incredibly important to have kind of that follow-up, that next step. And that's what we found to be the most successful.
There's so much going on there. You have to have something for them to remember you by, because they saw everything. They saw like all sorts of things, like people getting zapped and robots and all sorts of crazy, you know. So yeah, it's good to kind of have that hook, bring them back in afterwards, keep the conversation going if they're actually interested. And usually if they stick around for more than 5 minutes, they're usually interested. It's just maybe a passing interest sometimes, or they're just making conversation. But it's still good. It gets your name out there, and like they'll say, oh, I saw these guys, I talked to them. Maybe somebody comes through word of mouth instead of direct conversion. It's still beneficial to be out there and put yourself out there. It's tough, especially when you're just starting and things are like, you know, not so easy. But yeah, it was fun. Yeah, I was only there for the Friday and Saturday. I actually got in on Thursday, but didn't have a ticket to get in on Thursday. I'm not special enough. I didn't want to pay the $1,000 or whatever. But yeah, it's been fun, and I recommend it to people, especially if you're into making things and or showing off your making of things. I think that's kind of the big part of it, is like, you have this thing, you want the world to see it. Usually you end up going to YouTube. That's kind of how it goes. But then they eventually come, like, you know, to like fairs and stuff like that. And yeah, you can start like some like more interesting conversations and like learn, and then maybe pivot, even change what you're doing based on your interaction at these things. And that's kind of cool. Like, and like, you know, finding somebody else's kind of perspective on it, something that like they saw that maybe you didn't see it because you're so focused in and you can't see, you know, like these other things because you're just too close to the metal or whatever. And they're like back here from the, you know, the big picture view. They're like, okay, yeah, that maybe, but what about this? And that really, it's super helpful when it comes down to things like kind of reeling it back in and kind of intaking the kind of the feedback and kind of adjusting what you're doing, like if it's valid feedback.
Yeah.
You know what I mean? And yeah, I'm sure you got plenty of that, or at least some.
To go full circle to the open hardware side of things, I think there's a lot of negative connotation around AI for coding, AI for this, AI for that.
AI for anything.
And for anything, yeah. And with reason. 100% we understand it. We get it. And when we're trying to present to them like, hey, we built this tool that lets you build hardware faster than anything else you could. Yeah. And it's like, yeah, it happens to have, you can do everything manually if you want. It happens to have AI for automation to make things go a little bit faster. Sure. And they're kind of like, yeah, that sounds kind of cool. It's like, I might try it. And then all of a sudden we go, hey, it's like, we know people don't like AI. Kind of weird right now. But we realized that no matter what, AI is non-deterministic. It's going to hallucinate and make mistakes. That's
Yeah.
why we built a open source standard. We call it the Universal Hardware Description. That's the engine that powers the entire app. So the AI has zero say in what's correct and what's not. It's literally just pushing buttons. And the moment we mentioned that, that's when their entire body language shifted. They're like, whoa, hold on. That's really cool. And so we'd spend the next, 10, 15 minutes talking about how we make sure that, hardware is properly defined and spec'd out so that the AI doesn't spend all of its tokens trying to read through a data sheet just to hallucinate components and connections. And I can't tell you how many times that single conversation, that single flip converted so many people. They're like, okay, I actually have a lot more trust in this, that it's not just a vibe coded wrapper for some sort of agent to build something for you.
Yeah.
And so, yeah, we actually had several conversations. There's a gentleman from, I can't remember what department he's from. Mark actually talked to this gentleman here, but he works for Qualcomm, and he was particularly interested in the UHD, the Universal Hardware Description standard that we were building. And so, yeah, we connected, and he's like, I really like how easy and how well defined it brings components down from this massive data sheet, this massive list of documentation into this really nice clean package. So we were able to have like in-depth conversation, even with industry that was interested in maybe using that UHD alone, rather than just going through protoboard. So there's so many cool things that happen when you build something behind at face value. So that was a really good response that we got. Nice.
Yeah, I was kind of interested in this this universal language thing, and how it would consolidate the knowledge from like various artifacts into like a kind of a knowledge base. It's kind of cool. And I don't know, do you have like a website specifically for that, or do you have like a kind of a informational?
We do. I'm going to put it in the chat here. There's a link to the GitHub repo. We don't have a website yet, but the repo is live and it is open public. You can take a look at it. It's still a work in progress, so it's not going to be perfect, but this is a really a good start for describing what the overall description language looks like, how we do it, what we're doing. And we do have a library of components as well. It's not super extensive. We're putting a lot of focus into vetting the process of building this definition. So we've only got like maybe 200 parts in here, maybe less.
Okay.
But we've got a bigger library of components, over 1,000, that we're going to port over to the UHD once we feel like it's ready.
Okay.
Because it's kind of, there's no going back. The moment you have magic smoke come out of your project, you're immediately going to go back. It's like, okay, what went wrong? What pin was wrong? What was wrong here? So we want to make sure that this tool is very robust before we start depending on it too much. So hopefully here in the next couple of weeks, we're going to shift over. What the current system is, it's a legacy version of UHD, an early prototype version of it. We're going to shift into the full UHD protocol, framework, hopefully in the next couple of weeks. So protoboard will officially be 100% running on top of this description language.
Nice. Yeah, it's kind of it'll be like foundational tech.
Yes.
Very cool. Very cool.
Yeah. And this is open source. I mean, we want people to adopt it. We're working with, we're talking to manufacturers, distributors, couple robotic component manufacturers that we're trying to get them on board to the system. Because the whole idea is, look, people are going to start using AI agents to build everything, including hardware.
Yeah,
and
started.
our theory is that manufacturers would be willing to work with us, like adopt this standard so that any AI agent can just hook up to an API that they have, grab the necessary definition that they need to then build whatever project that they have. Whether it goes through a protoboard or not, doesn't matter. We want this standard to be universal for anybody to use.
Okay. Yes, it's definitely, it looks like it's got a lot of words, that's for sure. Which is good. It kind of gives some meat and understanding before like kind of like tackling the core coding challenges. I'm assuming that this is work in progress, and
yeah, does work. It does work really well, but there's definitely a lot of edge cases and bugs that we're still trying to iron out. One of the hard aspects of UHD is it's not just a static definition. Like we started off just doing a simple JSON, which everybody else is doing. There's nothing new there. Yeah. But there's a lot of times where you have to have some sort of calculation take place in order for that definition to be validated. And I'll give you an example. If I've got a power domain where my battery has a specific, amperage rating, total load on that battery, and I have 10 different components in my project, they all have different values of power requirements. And so it's not as simple as just looking at the data sheet and saying, oh yeah, this is good. You actually have to calculate what the expected load on that system is going to look like. And this is a good example, but we built this system so that it has the ability to do that. All of the scripts, all of the values is built into that definition so that you're getting real expected values based off of the actual component, not just the static data sheet by itself. And I think that's where it becomes really powerful, because now, and don't get me wrong, it's not like ngSpice. It's not LT-Spice or any of these analog simulators. We're not doing a full simulation, at least not yet. But a lot of that information is packaged into the part so that you could run multiple simulations, and it's just packaged really well together.
Yeah, cool. So yeah, hopefully this you'll come to share more about this as things progress, so that people can watch your progress. And
yeah, absolutely.
I definitely like having you on the show. You definitely are one of the key contributors to the show. Otherwise, there wouldn't be much show besides me drawing schematics, which is, I guess, fun for some people. But open hardware is kind of a big area, and like a lot of the open hardware guys are kind of close-minded about AI, and there's reasons. There's socioeconomic reasons for this, and I'm not like a huge AI guy, but I'm not going to say, no, you can't come on my show if you're talking about creating something with the clanker or whatever. It's, I mean, everybody's doing it, which isn't a really good reason to do something. But if you don't know how the technology works, things are going to be difficult for you when other things like come around, and like they're kind of dependent on this thing, and it wouldn't happen without it. And there's so many things that are happening now that would never have happened otherwise, because people just didn't know how to they couldn't complete the loop without it. And I mean, it's good and it's bad, there's always downsides to technology, and you gotta kind of use it wisely. Don't waste all these resources for something that is trivial to do otherwise. You know what I mean? If you can't do it, then you can't do it. I mean, that's one thing. But if you can do it and you're just being lazy, I don't really, subscribe to that, because it's wasting a lot of power and resources for that. And I think a lot of people like in the industry are just kind of gung ho about it. They were like, yeah, I'm do everything I do at work now is got some tie-in or whatever. And I'm like, oh, that's you. I mean, that depends on like what you're doing or how overloaded you are or whatever. There's so many different reasons why you would go to this. But yeah, it's not some miracle cure. It's definitely not what they're selling it to be. It is what it is. It's a tool to help you kind of aggregate knowledge. So yeah, it's been interesting. It's been an interesting couple of years with the AI stuff and LLMs. Like a lot of people like kind of just take all AI and just put it in the bin when they see that, this big corpo is like, stealing, or whatever they're doing, And I'm like, okay, but then before these guys were ever around, these machine learning and machine vision and all these other things that aren't LLMs, they were everywhere, and they're still around, and you still need them for things like robotics specifically uses a lot of machine learning stuff. You can't say no to AI if you want to make like a autonomous robot. That's like kind of nonsense. You know what I mean? So you got to figure out, what's good and what's bad. Like, do I use this tech to make my thing or not? And I mean, it really depends on your philosophy. I'd like to do things myself, but that's just because I'm vain or arrogant or whatever.
It's an acceleration tool. I think it's going to make things a lot easier and a lot faster and a lot more intuitive. In the world, it's going to constantly shift. I'm sure there's going to be more progress here and there. Yeah. The bubble is going to pop eventually, and
China will release another model that just breaks everybody.
Well, that's the thing. Look, I mean, people keep expecting this to blow over, and the bubble, the hype, yes, it will.
Definitely.
There's going to be foundation models. AI is still going to be around. It's a tool that's incredibly helpful, but it's not a Swiss Army knife. It's not a multi-tool here. I'll go on your example here. Robotics is a hot topic. People are saying it's going to be the next bubble. Could be physical. They call it physical AI. That's what investors are calling it now.
Oh boy.
And I feel like everybody's go-to is grabbing like an open weight LLM and stuffing it inside of a robot brain and be like, all right, learn how to walk. When in reality, it's a language model, not a movement model.
No. Yeah, there's so many different texts that would be better for this.
Like you're using a hammer to scoop up water. Like it's just you're not using the right tool for the job here. Yes, it's powerful, great to communicate. It's got a lot of knowledge base, but it's absolutely massive. And especially with open weight models, a lot of people, I see a lot of hype around this, and I think it's super silly. It's like, oh, this new open weight Kimi 3 just came out, this new Chinese model, and it's got like Claude and Soul 5.6 level intelligence. And I'm like, okay, cool. You need a server. You need a data what is it called? They're making them everywhere. I can't believe I'm having a brain fart right now.
Data center?
Data center. Thank you. I don't know why I couldn't get that in my head. It requires an entire data center, multiple servers to run an open weight Kimi 3 model. You're not running this on your local GPU or your laptop or inside of a robot running on a Jetson. Like that's not going to happen anytime soon here.
Nope.
And so people are getting hyped about the wrong thing here.
Yeah, well, I mean, if they have this like tethered to the cloud, all of it is at just the internet connection away, So
I disagree. Cloud, yes, you can. But me personally, I think for real robotic applications, the latency is just a no-go. You can make it work, but to run such a sophisticated model through a cloud connection has a lot of latency behind it.
Yeah.
Not to mention, these models are designed to think really long and hard, which means really quick response movements aren't
It's
possible.
useless. Yeah.
Whether you've got a good internet connection to the cloud or not.
Yeah.
So it's just, I think people's misconceptions are really kind of tied to this whole hype that is surrounding AI in general. And I think it really does a disservice to real innovation happening as a result of those tools.
Definitely.
But I don't know. That's just my opinion. And I'm biased. We're building a tool that uses AI. I'm biased, sure. But we also spent 2 years building artificial muscle technology for humanoid robots that had nothing to do with AI. Like, we built hardware, we sold hardware. We've been to in accelerator programs, hackathons. Like, we've built a lot of stuff, and we know what it takes to actually build real hardware.
Yeah.
And so with, AI being so incredibly useful, we want to take advantage of it. We want to make it easier for us to build hardware. That's my take on it. I'll stop rambling here.
Oh yeah, we need to put the maker chip
Yes.
project up here still.
I've been talking to Robert. I've got all of it. The maker chip version that I have, the PCB version, is completed, ready to go. But I am working with Robert and Mohib to connect Protoboard to devEco, because I want to be able to post our projects into devEco really, really well. And so ideally tomorrow we'll sit down and actually walk through getting everything connected and making it easier for that. So here pretty soon you'll actually have a lot of projects coming from our side, including the maker chip, the artificial muscle system that we built. Let's see what other projects that we got. We've got a bunch of projects. I'm trying to figure out which ones we're actually posting.
Yeah, I figure I'm just pressuring you to do the maker chip because it's going to be under my hub.
Oh yeah,
it's a project that we've been working on forever, and these things came out fantastic, super fantastic. They work perfectly.
They did.
It works to whatever specification that you were given. I found it like people were spilling them on like off the clip though, which is kind of. I guess you can fix it with stronger.
It was a last minute budget decision. So these are, I don't actually know what rated magnet they are, but they are originally designed for N52, and those suckers are perfect. Yeah, absolutely perfect. These guys are rated under that, so their magnetic is not quite as high. And we could not get N52 rated magnets here in time without costing a fortune. Yeah. So there are vendors out there like Alibaba, AliExpress. Like, we're gonna find a manufacturer that can make these for us a lot cheaper. Yeah. But in the time frame that we had for open source, we just made a last minute decision that this was good enough as a good representation, good prototype, and we've got the real version. That's definitely better.
Yeah. So yeah, I got a few like ordinary maker chips. Like,
me too.
Still do those without the magnets in them. They're good still. Like this one was from Heavy Falcon, a regular on the show.
I got one of those too, Heavy Falcon. And then I feel terrible, but I talked to so many people. I got one of these, and I'm trying to remember what his name was. Who gave me this one? Oh, it's got an RFID tag on it. Actually, I think I can. I forget. I can figure it out. I'll look at that later. Yeah. But to be honest, it wasn't really a big push. I think the first kind of breakout moment for us was because we made these for content creators. We made them for Sean Hodgins, which, by the way, he wore on his hat.
Yes, he did.
On his fireside chat. That was freaking awesome.
Yeah.
We made it for Sean Hodgins, Becky Stern, Crunch Labs, Hackpack, Arduino. Mr. Volt.
Edge AI Foundation.
Edge AI and devEco. Mm-hmm.
Yeah, I actually got to meet Pete Bernard from AJI Foundation
Nice.
on the trip.
I've actually met
Pretty
Pete
cool.
a couple times now. Once at the AJI conference in San Diego, and then again here. So maybe he remembers me. I don't know. Who knows?
Yeah,
Well, he got a really cool freaking maker chip out of it. So I don't know.
Yeah,
maybe
I'm
he'll
sure he
remember.
remembers. I mean, we're using devEco, and they're kind of tied into the devEco.
Mm-hmm.
They're benefactors, which is cool.
Yeah.
So we can't be too brash on AI, well, I mean, be kind of a weird fit.
Edge AI Foundation, that's completely different. That's a whole nother ballpark.
It's like machine learning, and it's not like the LLM stuff.
It's SLM. They call it small language model.
Yeah.
That's kind of what their focus is. How do I optimize my tiny little chip to run a small language model on it so that I can do things? For example, one company, when I was in San Diego, they were using a small language model to track how many people are in the room. No camera whatsoever. Like, they didn't know who was in the room. There's no facial tracking or anything like that. But they were using a sensor fusion to just determine how many people total. I think it was a millimeter wave. I'm not sure.
Okay. So bouncing radio waves off of people?
Yeah, they were doing something.
Maybe you can look at people with Wi-Fi nowadays.
Yeah, that's true. That is true. Non-invasive, and it wasn't connected to the internet. The only thing they had to do was, hey, how many people are in the room? What is the air quality? Like, how hot or cold does it need to be in the room? Like, they would do real world adjustments based on how many people were in the room.
Yeah.
Not connected to the internet or anything.
Yeah.
No intelligence beyond what was on the device.
Yeah.
And I thought that was really cool because that kind of solves both problems. People are very hesitant about AI. It's like, oh, they're tracking everything. Yeah, absolutely. But this is not connected to the internet. It's literally just taking the intelligence, hyper focused on one specific task, and then connecting it to a device that makes your life overall better. So I think Edge AI has this really stinking cool opportunity ahead of them. I think there's going to be so much cool stuff happening in the near future.
Yeah, and I've been watching them for a while. TinyML and
that's another one. Yep, TinyML.
They're kind of an offshoot of TinyML, actually. But yeah, it's really cool stuff. So I guess what else is going on in open hardware land? devEco IO launched officially at Open Source. I haven't seen a huge uptick yet, but I'm hoping for more projects to show up. And there's a contest coming up here that might bring in some eyeballs.
Nice.
I don't know if we're supposed to talk about too much before it launches. I think it's going to be soon, very soon.
Robert, how far are we allowed to talk? Are we going to kick off?
Not at all.
What?
The new competition that's going to happen on devEco IO.
Yeah, we can't talk about it. We can't talk about it like actually what it is or anything. But I mean, right now we suspect it will go live on the 27th.
Excellent. All right. Yeah. I've been I thought it was supposed to launch during the conference, but I guess there were some, hiccups with kind of the partners for the competition. It's going to be pretty big, I think, and it'll be the first through the devEco. Do you have any other devEco updates while you're on the air?
I don't.
You don't? No. How you doing? Are you feeling all right since the post conference blues?
No, I have I'm so backlogged.
Yeah.
Same.
Yeah.
Same.
I'm literally just trying to knock out every single thing I can off the list.
Yeah. At least you have a list. That makes it easier to kind of gauge where you're at in the progress,
Yeah.
But then sometimes you forget the things in the list or the devil's in the details, and this one item turns into like hundreds of other things you have to deal with.
It's true.
Yep. That's just work for you, though. So I guess I'm not going to probably go. I did bring up the ECP5 wireless design, but I'm probably not going to, since we only got 14 minutes left, I'm probably not going to do any design on that. But I did a fair amount of work since the last time I was on, kind of just spitballing the project. So we got the PMOD headers and LEDs and power supplies, battery management, and ESP32S3. So we're moving along. I usually add notes when I think of something I want to add. So I have a bunch of stuff I still have to add. User buttons, input clock, JTAG header, flash and RAM, SD slot. Yeah, the one of the more popular boards, the ULX 3S, is an ESP5 as well, and it has a HDMI output. I don't know if that's something that people would be interested in having on this, because then you can have like video apps. So you can run like some kind of HDMI or HDMI DVI output and drive like a computer monitor with your FPGA, which is it's for some fun hacks. So I was thinking of maybe adding the HDMI, but I don't know for sure yet. Depends on how things line up. The PCB itself is pretty small because of the original one, the ICE5 wireless, was the same form factor. I wanted to keep the form factor and get the way better FPGA on there, but it's looking pretty rough. Like it's not going to fit. So we'll see. Maybe I'll just increase the board size a little bit.
What about a display port, like a USB-C type display port output?
Yeah, I think that the trick is just having this kind of the brains to drive it. So DisplayPort it's like DVI, right? It's just like HDMI. Yeah. So I think that we could probably use a smaller connector like that, and that way we could get away with having have it on the smaller coastline. Right now, there's going to be the USB-C already coming in, but that's going to be talking to the ESP32, so that it's the coordinator. So it's going to program the FPGA either through this USB or wirelessly. It'll send the bit stream to the FPGA, and then the FPGA will do whatever you programmed it to do. So I think having outputs other than the standard PMOD, LEDs and buttons would be good. I just got to figure out which one I want to do. There's a connector standard that's pretty popular, that's used on a lot of FPGA boards called, I think it's syzygy. It's spelled weird. Let's see if I can find it real quick. Syzygy. FPGA. Yeah, so it's a standard developed by, what did I do? There we go. Opal Kelly, which is an FPGA board vendor. They have these high-end ones, the Arctics, Zincs. These are all Xilinx FPGAs, it looks like. Not as open as the one that I'm using, but also a lot more resources, except for maybe these low-end Spartan ones might not be about the same. It says end of life, though, so these boards aren't cheap. Like FPGA is never cheap.
Is that a single chip?
This is a single board, $4,000. So this is a Kintex. This is pretty high end, and it can do things like DDR4, super speed USB 3. That is fancier protocol, fancier PHYs on the chip, fancier memory configuration, DSP elements, things that are just higher end for like crazy, compute applications. and they're used a lot in robotics, and they can do like hardware like for like doing crazy things in data centers and making compute kernels to like dedicated to the load. But they usually end up using GPUs or neural processors or something like that in the data center. FPGAs have been like deployed in the data centers as well. But
Yeah,
this is standard was what I was looking for.
We've actually talked to a company that is taking FPGAs and building a data center, only FPGAs that can be reconfigured at a moment's notice.
Yeah.
Which was interesting. They were specifically using it to run like LLMs, but giving companies the flexibility to swap very, very quickly to a different infrastructure without having to do a complete overhaul, I think was their main advantage. What happened to my camera?
Your camera dropped. So so this thing uses it uses these high pin count, like high speed connectors to mate the two boards, which is going to do a lot like fancier protocols. Like you can use differential signaling over it and not worry about things going haywire or whatever. So I'm thinking of maybe adding a syzygy or something like that for like more advanced users.
Interesting.
Yeah, it's not a terribly complicated thing. It's just you have to have these pins that are kind of in this shielded and like close spacing, so you don't kind of lose the signal integrity over the connector. So, this is on the list of maybes for the board. Adding a syzygy connector, so I'm going to add that to this.
What does a connector like that look like? I'm assuming, I mean, it's an open standard, but I'm assuming there's only a few manufacturers that actually make those.
Yeah, I think this. We should probably need to know that if we're going to consume the standard, we need to know the part number for the part of the connector, right? So let's see here.
Pin count.
XC for
is that megahertz?
Yeah,
wow, that's impressive.
No, I think it can go pretty quick. Yeah, megahertz pin.
Yeah, 500. Yeah, max 5,000 megahertz. Okay, so that's what.
So you're talking gigahertz through the pins, which is insane. Okay, yeah, like it's for like doing Ethernet or USB-C or something that's really fast. So a USB like let's see if I can get this from the specification. Samtech part. Okay, so it's not going to be cheap, but it's going to be really reliable. Samtech parts are used heavily in the industry. Let's see. And they're really great about sampling parts. If you ever have to use one of their parts, super awesome about it. Yeah, go away. All right. So yeah, it looks like you can add like different features to it. Number of positions, friction lock, which is kind of cool. I wonder how many how many times you can cycle the connector before it fails. It's probably pretty good. But yeah, like the ones that they have on like the Raspberry Pi compute module, they're just dinky little connectors, and it feels like they're not so easy to solder, make prototypes from. So you want to, if you add this connector to your board, I think the Butterstick had it, you'll need a breakout board that plugs into it if you want people to do protos real quick or some kind of way to access it, because they're not going to want to solder these things at home. At least the average Joe isn't going to want to. So we'll consider it. It's definitely on the considered list. So I'm going to put a note in the schematic real quick while I remember. All right, let's see. Oh, garbage can header. The garbage can header was a trick that one of the senior engineers at EMAC, where I used to work, he used to like if there's any signals left after he's done routing and adding all the features and everything, he would just take the extra IOs that were on the chip and just put them into a connector next to the chip, or like, somewhere on the board, in case he wanted to like possibly use them or need them for anything that might happen. Like say you needed to do a wire mod or add a feature, you can just use this connector to proto the next iteration. And that's something I've grown to do, is that at least put test pins or test points on the spare lines, so that we have a little proto room. And like a lot of the guys, like when you do your first, like your very crude proof of concept ones, you just want to like make it big and don't worry about like the form factor so much. Just get all the features you want in there and break out all the lines, and don't worry so much about how it's going to look until it comes. You gotta reel it back. I mean, there's reality of like packaging and how you want it to be, actually, like what form factor you want at the end. But if you keep adding features, then it can be problematic. But
I typically go the inverse route. I'm a mechanical engineer.
Yeah.
And so my typical process for building a PCB is form factor first. Like I'll design the part that I want, kind of the ideal form factor, and then I have an outline that I want my PCB to be.
Yeah.
And then I have to figure out how to get everything on there, which is definitely a terrible way to do it. But it seems like it hasn't failed me yet. It's definitely created a lot of challenges. It made projects longer than they needed to be, especially for an initial prototype. But part of the whole design process for me is to go through and see exactly like, okay, I'll give you an example. The hat clip. So I've got, for the chips, I've got a magnetic hat clip, and it's a PCB. And I've got a version that has a battery hooked up to it and some pogo pins that the maker chip docks to and turns on some LEDs.
Sure.
And the form factor was created first. So it gave me an outline minimum that I could make a PCB out of. So the components that I chose for that PCB had to fit inside of that form factor. And there was even a moment where I had to consider, should I do a rigid flex PCB?
Yeah.
And have components, the pogo pins land on the fixed section, and then a ribbon cable to another PCB at the bottom holding the battery and any additional components that didn't fit on the top. And so that kind of forced me to focus on how I could get those components to be smaller to fit that specific application. And
it can be rough.
If I can't fit it in there, that's the only time when I go back up the chain and make adjustments to the design to then be able to fit the component structure. That's typically not the right way to do it. I don't recommend it, but that's just how my brain works better.
Yeah, you start with the form and then you add the function instead of starting with the function and then creating the form. Which is, I mean, it really depends on how your mind works, right? And they can happen simultaneously, or almost they could be competing goals, right? You want function, but form is like also kind of a consideration, and you have to find like the engineering trade-offs and find the right fit for like, getting the function whilst retaining the form. And this happens a lot with like mobiles and like, any kind of like consumer electronics, where it's just like there's a lot of like highly integrated parts so that you can actually fit the form and get less people complaining about how thick it is, or how heavy it is, or all these other things, power density and stuff.
That's an interesting question. So from your perspective, Michael, in a SoC or a ASIC,
Sure.
is that ever in the realm of hobbyist grade workflows, or is that almost exclusively in the price range of always being a
Well,
more company based endeavor?
yeah, it's not a small endeavor. There are some, if you wanted to make your own chip, there are some avenues now that are opening up. And I was considering having Tim Ethro come on to the show actually and show off wafer.space, which is a way to get
Can you show it?
chips manufactured for really cheap. I mean, like extraordinarily cheap compared to what it usually is. And hopefully I can get him on one of these days. He's going to launch another batch here pretty soon. So you can get like, $4 per die. So this is not the latest tech. It's actually quite dated, like 180 nanometer
Oh yeah.
technology, which it'll work for a lot of things, and it's really good for analog.
Interesting.
Yeah.
Does this have the same pricing model? You obviously, I don't know if you know this, but is this kind of the same pricing model that like PCB fabs do, where it's like a whole bunch of projects on a single wafer, and then you
multi-project wafer is what they call it.
Okay.
So, yeah, like these shuttles kind of aggregate like a whole bunch of designs, and then they can afford to like actually make the masks and actually do a run. So I'd like to bring someone on that's more knowledgeable and could kind of speak to it, like Tim. And I know a fair amount about it, but I don't want to just kind of like give very not so granular information. It's gonna be more like course, like oh yeah, you can do this, but I don't know like all the exactness. But this the idea of what he actually pulled off was pretty amazing. And if you follow the open PDK kind of progression, Tim was at the forefront, and he worked with Google and Skywater and eFabless and created like the first open PDK, which was the Sky 130, and then the one that he's using here is Global Foundries 180, which is a slightly larger feature size, but it's also much cheaper, like less than half the price. So it's really neat. And if you're interested in making a chip, I think the first step is kind of maybe doing if it's going to be analog, making like kind of some circuitry, like just kind of put together parts using like off the shelf stuff. And if it's digital, get an FPGA and kind of implement your core IP in that, and then you can go and then harden it into an ASIC. And it's not cheap, like still. I mean, $4,000 is still more than most people are wanting to spend on something.
Yeah, maybe. Well, it's the whole thing. Like PCBWay wasn't cheap initially. When they first started off, it was still expensive. And then over time, the more and more people jump onto the platform, the lower they can drive the cost because they can take advantage of the volume.
Yeah, I think they're more like the kind of like the Osh Park of chips essentially. And they just kind of they took the idea of a bunch of people wanting the same thing, and then kind of rallying together support and providing like something that actually allows them to do all this in the open. Like there's no NDAs, there's no super secret sauce, there's no hiding your design after you're done. It's just all out there in the open, which is really cool. So I really want to get him on the show to talk about his endeavors.
Please. I think I'll sign up for that one.
Yeah. Yeah, it's
Well-
just I got to find a time because he lives in Australia, and yeah, it can be tough. I don't know
Yeah,
what
okay.
time is it there
Interesting.
now. That's a good question.
Australia is 11 hours ahead of us, I think. I could be
So
completely
so
wrong.
it's like it's morning time for them, is what you're saying.
Yeah, it's about to be morning for them. Actually,
Okay.
do I have? Now I'll look at it later. But dude, that would be amazing if they could jump on. Because here's the idea for a startup.
Oh,
From
it's
my
11 a.m.
perspective,
Okay, come on.
a startup doesn't have Fortune 500 enterprise level budgets. Some do.
Of course not.
But for a hardware startup, this is actually really stinking cool because I've got a very specific example. We're prototyping a new controller for our fully electric artificial muscle system.
Sure.
And one of the hardest things to do is get a really clean signal from our sensors so that we know exactly what the temperature of the material is. And right now we're experimenting a new type of sensor that gets us much cleaner data that we can then turn around and do a bunch of stuff with. But that was the first objective, is let's get really clean data coming from the sensor so that we can build a more robust firmware software package to take advantage of it, to be a lot more responsive, a lot more accurate, all this good stuff. And in order for us to do that, we have like an entirely new PCB board, almost, worth of components needed to actively measure all of this. And most of them are passives. Most of them are just kind of like all these different things to help regulate that specific sensor that have
Sure.
nothing to do with the rest of the board.
Okay.
And in that specific instance, if we could build a prototype sensor, everything we would need for that specific thing, I would love to see what it would take to shrink the form factor down into something that I could package directly onto the muscle.
Okay.
One of my goals is to have a lot like how USB-C has a PCB on the connector. If you
Sure.
open up your cable, there's a PCB on the inside, and it's got
Yeah, a tiny one.
all the handshake components you need for it. I want a similar interface with the muscle that has a bunch of sensor and data all connected to that PCB, so that when you plug it into your controller, it doesn't have to have all of these external systems connecting to the muscle. It's literally already on the muscle itself. Like, that's one of my goals. So
Yeah.
it would be really interesting to see what it would take to go from this PCB prototype, this dev board,
Mhm.
and then actually shrink it down to something
Okay.
small and modular like that.
Yeah, I think we can take this one offline. I can, if you can, kind of give me some ideas on the type of sensor. Oh boy, we got a spam post. Yay, Twitch! Every time, without fail. So yeah, I think we're already up. Yeah, we're at an hour now, a little over actually. So we maybe should probably wind down the show. And it was fun talking today, Kevin, as usual.
Yeah.
And I hope people actually got some kind of fun information out of this. The effort's called devOSH, so it's open source hardware. And so if you have an open source hardware project that you want to share, you're more than welcome to come onto the show and show it off. And if you have protos, even better, so you can actually show it in action, because that's where kind of like, where the fun is, like seeing the results of all your hard work. And I like the montages where they show the construction of the device, which are fun. Like the time lapses of like schematic capture, or the 3D prints that you did, or like I think Kevin did one where you were at the makerspace doing a whole bunch of things to prepare some maker chip stuff. And it was pretty wild looking. Time lapses are fun. But yeah, it's just definitely open to open hardware projects that are compliant to standard. meaning you can actually reproduce it and it's not, licensed inappropriately. You're not stealing someone else's work and pawning it off as your own. So yeah, come on to the show and show us your stuff. And I'm always on the lookout for people. I know a lot of people in the space. And I've asked a few people to the show, but I can start kind of doing some legwork there to get some more people to show their neat open hardware projects. And there's so many of them out there. Just a lot of the times they're like, I find people, but they're either in a time zone that isn't conducive, or they're either like a little shy to the camera, or they just on their own thing, and they don't need an extra plug or whatever. It's just kind of like the passion project for them. But I'd like to see like all different varieties of open hardware, not just microcontrollers and FPGAs, but other things that are more application specific, and also mechanical projects. I really like those. Electromechanical ones are always like kind of the hit of the show. So I actually was commissioned to do a robotic Toto for the Wizard of Oz production. So that one is going to be fun. I'm going to make like a little robotic dog, and I think that would be a fun collaboration project where we can get like all the different skill sets together, because I mean I could do a lot of the stuff, but mechanically wise I could probably get somebody that could make traction a lot faster, especially with like compound like joints and like inverse kinematics and all the motor specifications and stuff. I know it's not fresh in my mind. I haven't built a robot in ages, but yeah, I think it would be cool to kind of put together like kind of a multidisciplinary team to work on that. If I can't do it myself, then I can probably find somebody that can help me out. I'm thinking I don't want to go too expensive on it. A lot of the big robotic dogs, they're using these really fancy, super expensive motors. I don't want to have to do that. So I'm thinking like hobbyist RC kind of quality electronics, if I can get it. I love like if it runs on wheels and like kind of hides the legs under there, I'm cool with that. It's fine. I was looking at this kind of hybrid where it was like it had wheels at the end of legs, which was really cool. This Fox thing that I saw on the YouTube, that would be really fun to do. It was. I'm probably gonna do RC, kind of to start, remote control, and then once we have that kind of worked out, and then they're able to use it for what they need it for, building in some autonomous modes. I was also considering making like a programming kind of like a basic programming language for it, like Scratch or like something simple that kids can do, because it's going to be for kids play. You need it to be able to set up and do its thing. It's not RC controlled. It has to take and do like a very specific sequence, and it's got to be kind of scripted. It can't be like doing crazy things, falling dead on the stage or whatever. Although it would be pretty funny, but I'd like it to just go off without a hitch. So I'm starting off with like the stupidest, crudest like model, which is like an RC car with a stuffed animal on top, till like, and then I'll like, if I have a Mark I, then I can put that aside and actually work on something that is actually a little more technically sound and more fun. There's going to be a lot of pieces to that. Because dogs, they emote, they got to have their barking, they have to have their the movements, articulation points. It's going to be a lot of fun, and I think it'll be a fun collab project for our for the open hardware initiative that we're doing here. because then we can all kind of put our skills together and make something neat, like a robotic dog.
Heck yeah. Yeah, keep us updated. I'm more than happy to collaborate on it if you're looking for people. I'm always looking for people to work on
Thing
it.
is, like if we go down that route, I mean, you can go way down that rabbit hole and end up with something that's going to cost like 50 grand or something for like a local production.
Yeah,
I'm
no,
thinking
I mean,
metal
like-
geared servos, nothing. Maybe
I think-
maybe something a little bigger. Depends on the joints, that like how much weight it has, and like all these other things.
the cost, I think, is a linear correlation to the angles of movement, the angles of freedom that you have for your specific dog. If you're wanting it to emote, you're going to have to add sensors and motors, servos, and some speakers.
Oh, I know.
That's kind of what level of complexity do you want it? Do you want the eyebrows to move? Do you want the ears to move? Like
I'm thinking dog mouth moves, dog head moves, and then that's so you got like two servos in the neck or whatever, and maybe one for the head, you get a solenoid or some other actuator there. And then I was thinking for each leg you'd have probably at least 2 servos, and then maybe motors like for the wheels at the bottom, so you can like cruise around on the wheels instead of walking, because it's not going to move fast. Like it's not going to move fast like a little dog unless it's got like wheels under it, or you have some really sophisticated like walker.
Well, I mean, we can do some digging here, but I've seen a lot of open source quadruped robots that are very impressive in their ability to actually move normally, and they typically just have two servos, 2 motors per leg, and then everything is tendon driven.
I've seen that, the capstan or whatever they call it to drive.
That and a couple other forms, but honestly, cool. I don't think it's that complicated. It really comes down to how quickly the motor can actually respond to adjusting its balance. A really deep geared servo is probably going to be too slow. So that might be the most expensive part of the build if you want it to move. But 100% doable.
Oh, definitely. Well, that's why like I would have been like, no, I don't want to bother, because I could come up with something pretty quickly. It's just I want to make sure that it's something that's actually convincing, because if it's just like an RC car, it's not going to be super convincing. But as long as it doesn't look terrible,
I would almost say like my direct line of thought here would be to find some sort of stuffed animal.
Yeah, that's what we already kind of went down.
We'd skin it.
Just buy it and fit it it to the machine.
So we've got our form factor, we've got our kind of like our limbs and everything. That kind of gets us good proportions. Then we find a open source quadruped project, and then use that as our inspiration for building our custom setup to fit in the form factor. I feel like that would be the best way to do it, because there's a lot of variables that have already been solved in that project, and then all we have to do is scale it to match our dimensions.
Definitely.
So I feel like that would be a lot simpler to get it right in a budget-friendly way than starting something from scratch.
Oh, definitely. I have my 3D printer. I'll need at least it's like 12 to 14 actuators in there, so maybe more, maybe like 20. You got something that makes noise, and you also have to have the kind of maybe sensors like for different things. Of course, like maybe an accelerometer, gyroscope for poise, and maybe like AI vision or machine vision would be cool to have. If we got down that rabbit hole, we could venture to make it completely autonomous as well, which would be fun. But like when it's done, I'm actually keeping the thing, so
Okay.
I can put a little more money into it. Like there is no budget. I'm just gonna have to pay for it essentially.
That would be that would be a much larger scope of having it be semi-autonomous.
Yeah.
Having the necessary, it's one thing to put the sensors in there, but in a convincing way, putting the sensors into the robot in a convincing way that doesn't just completely destroy the overall form that we're trying to go for is a challenge.
Yeah, I think with the inertial sensors, it's just got to be at the center of mass.
Yeah, that's fine.
This is easy.
I would put, just because we have the room, I would put IMUs on like 5 different spots.
Okay.
One on each leg so that you can actually tell what's happening there. Like, you could definitely have a lot more internal things, but I'm thinking cameras and sensors that
of course and motor encoders.
Yeah. You could do something like ultrasonic sensors.
That'd be cool.
Which could go through the fur.
Yeah.
Bounce back and detect, like, that would be completely hidden.
Maybe the eyeballs, maybe, so you can like hide them in like plain sight.
Yeah, like you can, but the eyeballs are hard because it's X amount of joints from the center of mass, which means you have inherent instability that kind of works up the chain.
Yeah. So you want it to be like on its chest or somewhere that's like a
if you've ever seen the Spot robot from Boston Dynamics or any other like quadruped robot, it's all in the center of the chest, like the center of mass. Everything is. Yeah,
makes perfect sense actually.
It's hard to do external.
It's not out on a tether, so it's not vibrating out and like moving, and
not to mention, I think a dog's like neck and its head just moving back and forth, I think that's honestly approachable. I don't think that's too crazy.
No.
But another reason why is the inverse kinematic calculations you have to do by adding extra joints to a head to move around.
Yeah,
becomes hard as well. So you end up having to upgrade to like a Jetson in order to.
Yeah, I don't want to throw too much hardware at it. I want to make it as efficient as possible.
It scales so fast. And it's really hard to find a good fit.
I don't want it to cost like thousands and thousands of dollars. Is the trick. Although if we end up making it like expensive, then of course I'll have this expensive toy to mess around with. Bring it with me.
What's going to cost thousands?
We're making a robotic dog.
Oh. For open source next year?
No, it's for a play for my daughter.
For open source, and that hands out maker chips.
It'll poop out Tootsie Rolls.
No, it poops out maker chips.
Ooh.
No, it shoots maker chips out of its butt and its mouth.
Like a pet.
Just both sides. Yeah. You get a chip. You get a chip. Yeah,
I'm launching I'm putting together the devEco.org site.
So what's up with that? What's the reason for making the site?
So we kind of commandeered the devEco.com and turned it into the LLC website.
Sure.
And since the devEco is intended for transitioning into a nonprofit,
right?
The .org domain makes sense.
Yes.
And we're actually getting really close. I found someone.
Okay.
I found someone, and I'm very excited actually. She has already begun onboarding, and that means that we are getting very close to actually issuing out the incorporating as a nonprofit.
Your third partner? You're the elusive third partner?
No, I want to be like really, really kind of like, I guess, I really want to like, what is it? Transparent on this, right? So there is devEco Consulting, LLC. There is devEco, the community engine, which will transition into devEco, the foundation. And so assets that assets need to be organized properly across these two arms. And while they share a namespace and kind of live under this umbrella as siblings, you could almost consider them, they do serve different purposes and run operationally differently.
Okay.
Right. So this person that kind of I see it pretty much in stages at least, essentially comes on as CEO or president of the foundation, right? Like she comes on and she is the boss of the foundation, but it's still guided by a group of board members that will be established and represented in a way that makes it fair. So ideally, and this is something that when it does surface, something that I'm sure she will push out there and kind of like find out or collect data on this. But it's basically like, one board member gets voted in every year by the dev core. So there's always going to be a dev core member on the board. One board member gets voted in by, I don't know, X and Y. So like it's a distributed, board of directors.
Very cool.
Yeah.
Very cool. Yeah, I'm excited to see it grow and thrive. So that puts us at about an hour and a half. I think we can call it.
Looks like Kevin left.
Yeah, it looks like he dropped.
He was just like, screw this.
Mic drop.
Mic drop.
Yeah.
But
it's
yeah,
always good to have Kevin on. He fills in a lot of
he's good, right?
The time with interesting conversation. So yeah. Do we have any other things we want to announce before we call it? Or are we good?
I think we are good. Pretty sure
right.
we're good. I think.
All righty. Well, I'll see you in 2 weeks. If you're on.
Wait, why 2 weeks? Oh, we're doing it bi-weekly now?
Yeah, I'm not doing weekly anymore because.
Yeah, it makes sense. Bi-weekly's better.
Yeah, I think it's just too much, and I didn't like hounding people like too much about it, and I ended up just kind of being out there by myself, and it's probably pretty boring after a while. But,
yeah, I'm trying to just make it a point to make sure I'm here, and then eventually I'll be here and well equipped and start turning my camera on. But
start making open hardware because that's what you want to do.
No, that's for you guys.
Ah.
But no, I mean, with this new person who's coming on, she will actually take charge of the LinkedIn and the social media channels, and so like it
nice.
Becomes a lot more formal, right?
Okay, well, I'm definitely going to need to get to know them.
I'll put it to you this way, Mike. You met her already.
Okay. All right.
But yeah, do you have a minute real quick after this call closes out to talk about something?
Sure. Yeah. Let me just close it out real quick.
All right. See you in the dev cave.
We'll see you in a minute. All right. So that's it for this week. We'll be on again in 2 weeks. And the agenda is posted on the GitHub repository. So go out there, and you can also look at devEco.io to find kind of more information about the project because there's a hub there. All right. So we'll see everyone next show. Bye.